about using a novel data-driven approach to identify intersectional inequalities in cancer care. So, I mean, with these bits, we've already gone through these earlier on in this set of talks, so I won't go into those too much. But as I say, I'm specifically looking here in inequalities in cancer care, and I'm trying to identify that it's important to correctly categorize populations, as poorly designed research can reinforce inequalities. An example, and this is where we start to get into intersectional analytical approaches, which again we've touched on, but one good example that's happened recently came up with the COVID pandemic, and this isn't an example of an intersectional approach, but I think it's good to highlight as a really good example of inappropriate categorization, where if we look at an ONS study that was conducted looking at COVID-19 mortality, initially done aggregating the Bangladeshi and Pakistani populations, and they found that once disaggregating these, they found that there were stark differences in mortality, and these were masked initially in the initial analysis. As I said, this isn't intersectionality, but the ideas of intersectionality help to potentially categorize patients better and therefore reduce the chance of masking these important data. So one big thing that comes up with intersectional approaches is how do we produce these sort of reproducible and transparent analytical pipelines. These can be quite complex analyses, and Neil's already touched on Dexter and the case study that we did, and I just wanted to highlight that these allow for what I just mentioned above. So now when we look specifically into cancer care, so my PhD is on blood cancers commonly treated with transplants, so I looked at non-Hodgkin's lymphoma. And here is just a very simple point prevalence over from 2006 to 2020. And here is the same information but stratified by ethnicity. Here we've grouped, aggregated others and mixed categories. But the key thing I want to take away from this is this the right way to look at inequalities? Now, this is where we get into intersectionality. Crenshaw quoting, "All the women are white, all the blacks are men, but some of us are brave," talking that univariate analyses of race and sex were underestimating inequalities experienced by black women. So it's potentially within the data we look at that the interdependent effects of different variables are important to the outcome of interest. Now, there are approaches to intersectional analyses out there. Here is a good example, and also an example of how these analyses can become complex very quickly. Actually explaining and sort of visualizing these results and reporting of these results can be tricky. But also, if you look in the literature, looking at these approaches, such as the additive effect of categories, doesn't always appropriately identify those inequalities properly, such as what Crenshaw showed in her research, looking at when you added together the effects of inequalities with men and women and the inequalities with the black ethnic group and the overall population, that additive effect didn't add up to the interdependent effect of these variables. So what did we try to do about this? So we're creating a framework and a tool here. Now, it's important to mention that this is very much more of the descriptive part of an intersectional analysis. We hope to add on to this in order to have more of an analytical part to this. But for the moment, what we wanted to do was try to cluster groups together. So let's say you've got here, it's just an example here with age category, sex, and ethnicity. And what we've done is we've calculated some metrics against each of these intersectional groups and clustered the results together. So this is using point prevalence and incidence rate, which is part of our pipeline in our analogy autoanalytics. And this is just an efficient, easy to configure way to start exploring similar outcomes within these intersectional groups. And the idea is from this, we want to export labels of groups clustered together which show similar outcomes, balancing that the amount of patients we have in each group, but also reducing the chance of missing these important bits of information. So rather than doing an intersectional analysis, so on the analytical side of things, on every single stratified group, we're actually using the clusters instead and assuming that these groups within these clusters show similar enough outcomes so that we can treat these, so we can aggregate these together in these analyses, which for certain tools and things that analyses that have been done in the literature that look analytically at this gives more statistical power into this. So as I said, this is just the framework that we got to this, which also will hopefully allow for potentially more intersectional analyses in the literature, because again, these have been done, but there's not a standard for this yet, or an easy to use framework yet. So one of the key aims for this is hopefully it will allow for research to start playing around with this idea of analysis and increase the knowledge base of this. Future aims, I've mentioned some of these: easy to export cluster labels for downstream analyses, improve time series interpretation of clusters, assess the effectiveness of the method on a well-documented use case, and use this method to generate new findings. Thank you. Here's some further information. I'm happy to answer any questions.